In this video, we're going to look at multiplying and dividing complex numbers that are in polar form or modulus argument form. So, if z1 is x1 plus I y1 and z2 is x2 plus I y2, these are just the common notations of just how to write a complex number in what you would call Cartesian form or rectangular form. Then we have these four important results that we're going to look at in today's video. So the first one says that the modulus of z1 times z2 is the modulus of z1 times the modulus of z2. The second one says that the modulus of z1 divided by z2 is equal to the modulus of z1 divided by the modulus of z2. The third one says that the argument of the two complex numbers multiplied together is the sum of the separate arguments. And finally, the argument of the quotient or the fraction of z1 and z2 is the difference of the arguments, like this. So I always remember these two here because they're kind of easy to memorize. But some people, they get the second two, the ones involving the arguments, a bit muddled up or confused. I always remember that they kind of work the same way as logarithms, right? Because it's like log of z1 times z2 is log of z1 plus log of z2. So I always, and same thing with the second one here. So I kind of remember them because they're very similar to logarithms. That's how I remember them. But this is the idea. So we're not going to prove them in today's video, but we're going to look at an example. And it's going to be a way to really quickly divide two complex numbers or multiply them together without having to actually cross multiply everything, because we can just look at the modulus and the argument of the complex numbers. Because remember, a complex number can be uniquely identified by its modulus and by its argument. So that means that if we know the modulus and argument of a complex number, we know the whole complex number. Let's have a look. Okay guys, so here's an example. We get given two complex numbers that are already in polar form, those there, z1 and z2, and the question is to find z1 multiplied by z2. So before this video, you might say, okay, and then you might have to literally cross multiply it all out and expand it all out, or maybe you turn the causes and sines back into x plus iy and get rid of all the trigonometry. Whatever you do, it's going to be really complicated, right? But here it's nice and simple because we have those four results. So what I'm saying is, to get the new complex number, the product, I need to know the modulus of z1 times z2, and I need to know the argument of z1 times z2. But I can use those formulas that I'm just going to put down again here. So there they are. We're going to just use them. So first of all, we need to work out what the modulus of z1 is and what the modulus of z2 is. Let's write these down. So the modulus of z1, just by looking at it, guys, it's the number 2, right? Because remember, when you write your complex number, it's written as the modulus times cos of the argument plus I sine of the argument. So just to identify everything, the modulus of z1 is 2 and the modulus of z2 is 4, because those numbers are the ones that are outside, okay? Then we need to write down the arguments of each of them. So the argument of z1, remember, that's just the same thing as like theta when you work out the argument. See my previous video if you need to have a look at it. But in this case, the argument of z1 is just 5 pi over 12. And the argument of z2 is just pi over 12, just by looking at it, right? So now what we can do is we can say, let's now go and look for the argument and the modulus of z1 times z2. Let's start with the modulus. So the modulus of z1 times z2, like this, where they're all in the same bracket here, is just the individual moduluses times together. We're going to use this kind of formula there. So it's just going to be 2 times 4, which is 8, nice and simple. Now we need to know the argument of z1 times z2. Well, for this one, we need to add the arguments together. So it's going to be 5 pi over 12 plus pi over 12, and we're using this one here. That's 6 pi over 12. 6 pi over 12 is the same thing as pi over 2. So the argument of the product of the two complex numbers is pi over 2. So that means that we can write down the final answer, and that is that z1 times z2 is the modulus of z1 times z2, which is 8, open bracket, cos of the argument, which we now know is pi over 2, plus I sine pi over 2. And as you can see, the benefit here is that that was quite quick, right? That was really quick, actually. And this can be simplified even more. If you don't want it in polar form or modulus argument form, that's okay. We can just convert it back because pi over 2 is quite a nice number. But this is one of the many benefits of putting a number into polar form. right? Because when a lot of people learn about polar form, they say, what's the point? I feel like I'm making it more complicated. But actually, you can use it to multiply and divide. So doing one more round of simplification here, we can see that the new complex number z1 times z2 is just 8, and then open bracket, and then we can write down what these are. So just pi over 2 in general, the number pi over 2 is representing 90 degrees here. Cos of 90 degrees is 0, and sine of 90 degrees is 1. So it simplifies to just this, and of course this expands out to just give you 8i. So we go from quite difficult because it's in polar form and you'd have to expand it all out. That seems terrible, seems gross, to actually all of a sudden it's like, oh, well, as long as you know how to get the modulus and get the argument of the product, we're chilling. So now let's do the same situation, but instead of finding z1 times z2, let's find z1 divided by z2. So now we want z1 divided by z2, just like that. How are we going to do that? Well, guys, we're going to go up here, remind ourselves what each of them are, and we're just going to use the formula again, and I'm going to write down some more stuff. Okay, and you can see what I've done there. I've just replaced our little formulas with the equivalent for dividing. So we're looking for z1 over z2. We need the modulus of z1 over z2. But to do that, we can just take the modulus of z1 and divide it by the modulus of z2. So the new modulus of this new complex number that we're creating, the modulus of z1 divided by z2, is just the modulus of z1 divided by the modulus of z2. And in this question, that's going to be 2 divided by 4, which is, of course, a half. So this is a half. Now we need the argument of z1 over z2. Okay, and what's that? Well, the argument of z1 over z2 is the argument of z1 minus the argument of z2. So we're going to take them away. So the argument of z1 is 5 pi over 12, and the argument of z2 is pi over 12. That's going to give us 4 pi over 12. And 4 pi over 12, let's write this down, 4 pi over 12 is the same thing as pi over 3. So that's our new argument. And what that means is the new complex number z1 divided by z2 is the new modulus, which is a half, times cos of the new argument, which is pi over 3, plus I sine of the new argument, which again is pi over 3, just like that. And now we found z1 over z2 in polar form. And if you wanted, you could of course do the same thing. Remember, pi over 3 in degrees is 60 degrees. Cos of 60 is a half, and sine of 60 is root 3 over 2. So we get this, and you can expand this out if you want, and you can get a quarter plus root 3 over 4i. And so what that is that is z1 divided by z2 in rectangular form or Cartesian form. Cool. So that's the idea, basically. So just going back up here so we can admire the formulas once more. But remember this, guys, there's 4 different formulas. There's 2 for multiplying, there's 2 for dividing. There's 2 for the moduluses, and there's 2 for the arguments. So these are all worth remembering. The moduluses, as I say, I feel like they're kind of easy to memorize. The arguments, they're not as easy, but remember, they work the same way as if you took logs, right? So log of z1 times z2 is log of z1 plus log of z2. So if you know about logarithms, you can kind of just remember it as it's the same formula as for logarithms, but it's just arguments. So the idea of what we've done here is we've found a very nice way to essentially take 2 complex numbers that are in polar form, or you could convert them into polar form, and find a nice quick way of timesing them together or dividing them. That's a lot better than doing first outside, inside, last, right? Using FOIL, expanding it out. Much nicer this way, which is really, really good. If you're wondering, can we get a proof of this, please? Because you've just pulled this out of thin air. Yes, of course we can. And the cool thing is about this is that it's not difficult to prove this stuff at all. And it's not a coincidence that the arguments are the same as logarithms. It's not a coincidence at all, because it's involving exponential functions, but we'll look at that in another video. So what I'm thinking for the next video is I might do a derivation of this using only polar form, and then I'll do a nice, much easier way using the exponential form of a complex number. So the next video on complex numbers will be a derivation of this, but it's not the easiest way to do it. It's just it's fun. It's a fun way of doing it. And then I'll show you the kind of actual way that you should do it to not, spend a bajillion years on it. But hopefully that makes sense, guys. Thank you so much for watching. As always, please do not forget to subscribe if you found this video helpful, and I'll see you in the next glorious maths video. Cheers.